In 1901, a team of deep-sea sponge divers off the Greek island of Antikythera descended into the dark waters of the Mediterranean. At the bottom, they stumbled across the wreckage of a Roman-era cargo ship. The site was scattered with familiar antiquities. Looking at these encrusted clay amphorae, the classic storage jars of the ancient Mediterranean, archaeologists established the standard timeline for the ship and its cargo. But among those recognizable artifacts, the divers pulled up a small, heavily corroded lump of bronze. As you can see in this photograph, it looked like a green, crusty rock, appearing out of place next to the marble statues and pottery. Intrigued, this damaged piece of scrap would eventually force a complete reassessment of the limits of ancient engineering. When researchers finally examined the fragments in a laboratory, they realized the exterior corrosion hid something unexpected. Hidden inside the rock-like shape was a system of precise, interlocking geometric gears. Mechanisms with this level of precision typically belonged to the clockmakers of the Industrial Revolution, putting this artifact nearly 2 millennia ahead of its time. Based on the shipwreck and the specific design techniques, the object was securely dated to the 2nd or early 1st century BCE, pointing directly to ancient Greek craftsmanship. This presented a glaring historical contradiction: advanced mechanical technology resting at the bottom of an ancient shipwreck. To figure out what was inside those fragile, corroded fragments without destroying them, modern researchers utilized high-resolution CT scans and 3D modeling. The scans revealed dozens of individual bronze gears stacked in an intricate, layered structure. While we use digital algorithms to see these components today, highly skilled Greek craftsmen had to calculate the geometric ratios and painstakingly cut every single one of those tiny gear teeth by hand. The scans also picked up microscopic text. This bronze tablet features rows of ancient Greek inscriptions that researchers translated, acting as a built-in user manual for the device. These deliberate instructions, combined with the complex internal layout, proved this was a highly sophisticated machine designed for a specific purpose. After decades of analysis, researchers determined the Antikythera Mechanism functioned as a highly advanced astronomical calculator. The user interface was straightforward. By turning a simple external hand crank on the side of the wooden case, the operator set a primary internal gear into motion. That main gear then transferred its physical motion through a complex train of smaller secondary gears. These gears calculated mathematical ratios, rotating hams on a front dial to model the cycles of the sun and track the zodiac constellations. The internal gear train also simulated the moon's orbit. This grid of lunar phases shows the exact celestial cycle the machine replicated, keeping track of the moon's changing position in the sky. The mechanism was also calibrated to predict dramatic celestial events, specifically mapping out the timing of solar and lunar eclipses, as shown in this sequence. Until this point, astronomy largely relied on the passive observation of the sky. This device turned the movements of the heavens into an active mathematical equation that could be solved through physical motion. The ancient Greeks observed the mathematical patterns of the universe and captured them inside a mechanical box. The significance of the mechanism lies in its sheer complexity. These fragments demonstrate a level of technology that historians previously assumed was non-existent in antiquity. Ancient texts did contain descriptions of sophisticated astronomical instruments, but for centuries, those accounts were treated as myths or exaggerations because modern historians lacked physical evidence. This solitary artifact provides physical proof of a lost lineage of engineering, a tradition of craftsmanship that failed to survive the centuries. We still don't know who built it, where their workshop was located, or who owned it before it sank to the bottom of the Mediterranean. This was a machine built to calculate astronomical variables and output data through mechanical motion. The Antikythera Mechanism is a glimpse into the true capabilities of ancient Greek science. It suggests that highly sophisticated mechanical knowledge can flourish and then vanish for centuries before being rediscovered.